AC before rectification. I can easily detach. This is DC after rectification. I cannot detach. Welcome back to the Vintage Electronics online course. We are now learning the second lesson in Basic Electronics. These basic lessons are available to all viewers, not only members. However, the technical lessons are available only to members. Full details about membership are given in the description. If you are interested, please join. In the last lesson, we learned about the test lamp, multimeter, resistor color code, and more. I posted that video as a short. Within 1 week, around 4 lakh viewers watched it. Some viewers asked for the diagram of the test lamp. I will post a separate video for that. In Vintage Electronics, there are 2 types of power supply. One is the transformer, and the other is the battery. This type of cell is mostly used in vintage devices. Now let us first understand the transformer. A transformer has primary and secondary. In most vintage sets, the primary is designed for 230 volts AC and the secondary is designed for 9 volts, 12 volts, and so on. There are 2 types of transformers, step up and step down. This is the symbol of a transformer. This side is the primary and this side is the secondary. If the number of turns in the primary is greater than the secondary, it is called a step-down transformer. This type is commonly used. Now, if the number of turns in the primary is smaller than the secondary, it is called a step-up transformer. It increases the voltage. Now the question is, how do we identify which is primary and which is secondary? Some transformers have labels like 230 volts AC and 12 volts AC. But if there is no label, we can identify it in another way. The inner winding usually belongs to the primary. The outer winding belongs to the secondary, which is 12 volts AC. If this is not clear, we can use a multimeter. The primary has more turns, so its impedance is high, around 100 ohms. Set the range to 10. Before testing, adjust the 0 knob to 0. Be cautious, hold only one side. Now it shows 10. So 10 multiplied by 10 gives 100 ohms. This is the primary. 230 volts AC. Now let us check the other side. Since the resistance is low, set the range to 1. Again adjust to 0. Now it shows around 5. So 5 multiplied by 1 gives 5 ohms. This is the secondary. 12 volts AC. Now let us understand AC and DC. A transformer does not work with DC. I have connected AC supply to this transformer. Now we get 12 volts AC at the output. This converts 230 volts AC into 12 volts AC. Now, what is AC? In AC, we cannot define fixed plus and minus. But in DC, we can clearly define plus and minus. In AC, when one side is positive, the other is negative. And it keeps changing. It changes 50 times per second. That is why it is called alternating current. In DC, plus remains plus and minus remains minus. There is no change. In vintage sets, AC is converted into DC. For this, we use a rectifier circuit. A rectifier consists of 4 diodes and 1 capacitor. Now let me show the function of AC using an electromagnet. If DC is applied, it becomes a strong magnet. If AC is applied, it becomes magnetized alternately. Because the frequency is 50 Hz. Now I connect 12 volts AC. 12 volts is safe and will not give shock. See, it is magnetizing alternately. So it produces vibration sound. Now I connect the same with a battery, which is DC. This is also 12 volts. Now it becomes a strong magnet, and the clamp cannot be released. This is DC. The frequency of DC is 0, because polarity does not change. The frequency of AC is 50 Hz, which means it changes 50 times per second. Now let us see how to use a transformer as step-up. This transformer gives 12 volts AC. But if we supply 12 volts AC to the 12 volt side, we get 230 volts AC on the other side. So 230 volts is stepped down to 12 volts. And again stepped up to 230 volts. This is a 230 volt lamp. Connecting this lamp to the 230 volts side of this transformer. If I touch the 12 volt side, it is safe. But the 230 volt side may give shock. Now, to convert AC into DC, we use a rectifier. This is a bridge rectifier. It has 4 diodes and 1 capacitor. The capacitor has polarity. The negative side is marked. The positive side is usually not marked. 2 important points while connecting a capacitor. First, polarity must be correct. If reversed, it may burst. Second, voltage rating must be sufficient. Otherwise, it may get damaged. This is a diode and its symbol. It has 2 terminals, P and N. A diode is a semiconductor. It allows current in one direction only. In forward direction, it allows positive. In reverse, it blocks it. That is why it is called a semiconductor device. Now, 4 diodes and 1 capacitor are connected like this. This is AC input and this is DC output. This is the waveform of AC and DC. AC goes up and down, positive and negative alternately. DC remains constant, no variation. In the first half cycle, the top is positive and the bottom is negative. The positive will pass through this diode and so this line is positive. The same time, the negative passes through this diode and this line becomes negative. In the next half cycle, the polarity reverses. But in both cases, the output remains the same direction. So we get DC output. Now I have connected 12 volts AC to the rectifier. The white wire is negative and the red wire is positive. Now we check using the solenoid again. See, the bulb glows dimly. Now it becomes a magnet because this is DC. The clamp cannot be released. Now let us try with AC. It vibrates due to alternating current. Hope you understood clearly. The frequency of AC is 50 Hz. The frequency of DC is 0 Hz. In the next lesson, we will learn about voltage, current, power, and the function of an eliminator, which is very important for a service engineer. I hope this lesson is useful to you. Please teach your children also. Until the next lesson, thank you and goodbye.